Good afternoon, everybody. Thanks for coming to this joint talk with Damien. So my name is Jean-Marie Verdun. I do work at HPE. I'm part of the Advanced Engineering Group. So you might have some questions about why HPE at OCP. For the one who are not familiar about what HPE is doing inside OCP, we are doing a lot. And we are integrating OCP technology inside our own systems. So all the ProLiant Gen 11 portfolio is coming with some OCP gears inside. So we do have OCP NICs, we do have OCP storage controllers, and we keep enhancing that. So we are also supporting open source firmware on the HPE ProLiant Gen 11, and that's the main purpose of this talk for today. And we are also a very active member of the CMHS, which is an upcoming technology coming up from OCP. And I think that's really a critical thing which is going to happen. That's not the main purpose of this talk for today. We are going to speak about OpenBMC. How many of you are familiar with OpenBMC in the room? So don't be shy. Oh, that's a great news. It's more than usual. So for the one who do not know what OpenBMC is, this is an open source implementation of a baseboard management controller software stack. So usually this is implemented through a proprietary technology. On HPE platform, that is called ILO. On Dell system, this is called IDRAC. And on other ODM systems, it could be coming from AMI and called AMI Megatrend and Megarack. And this is used to control the servers, just how to turn it on, how to turn it off, and monitor the state and the health of the system. So that is a very small component inside a machine, but this is a very critical one. And there is a lot of innovation coming up around OpenBMC and the BMC software stack. So as I said, I'm here with Damien, who works at OVHcloud, and he's going to introduce you OVH. And we will go through a couple of innovations that we are working on together. Just go ahead, Damien. Welcome.
Thank you. Hi, everyone. I'm Damien. I'm working for OVHcloud as a software developer. And part of my job is working on OpenBMC. I'm collaborating with our motherboard providers to put our first firmware into production. And I'm also participating in more innovative projects like this one. So let me introduce OVHcloud, my employer. So we are the largest European cloud service provider with 42 data centers in the world. We have more than 1.6 million customers. We have more than 100,000 servers in the data center. And one specificity of OVHcloud is that for most product ranges, we build the rack, we build the chassis, so that we can better integrate our homemade water cooling solution. We've been using water cooling for a long time now. And we've also recently contributed to OCP with two new white papers. Sorry. So why did we collaborate? HPE was looking for a European partner to test the latest OpenBMC solution on their ProLiant Gen 11 server. And at OVHcloud, we were looking for a partner to ramp up on the project. And for the anecdote, Jean-Marie and I, the first time we met, it was at OCP Global Summit in San Jose 3 years ago, I think. So who knows, maybe today or tomorrow you will be meeting someone and you will be presenting a session in a few years. It happens. As for the collaboration, we heavily rely on Discord because Jean-Marie is in California, I'm in France, Lyon, so not always easy to see each other. Okay, so let's recap the challenges we face with legacy firmware. First, we are strongly dependent on the supplier. Dependent for the security fixes, for the bug fixes, for the release lifecycle, for the head of support. And I'm also part of the team who integrates the new BMC in OVHcloud infrastructure. And I can say that I spend a lot of time waiting for bug fixes from the supplier, which is good since I can spend more time on OpenBMC. But it takes way too much time to release a new product, in my opinion. So as you know, it's a black box, so it's hard to debug, it's hard to adapt, it's hard to modify. Also, the API are not standardized, and so are the features. They heavily rely on recommends. And for example, if you want to change, I don't know, the duty cycle, we have to map this motherboard, this recommend, this motherboard, this recommend. So hard to maintain. And even with new standards like Redfish, even if at OVHcloud we push to use Redfish HTTP multi-part method, they all come with their own OEM parameters and own behavior. For example, on one motherboard, we just have to power off the motherboard so that the BIOS update can start. On another motherboard, we will have to power cycle, so different behavior, and yeah, have to maintain. And also, the update processes do not scale well. They are based on edgy concepts. For example, for bug fixes, we have to update the whole flash. It's not what the customer expects, generally speaking. And this is one of the main challenges we will try to address with our proof of concept. So yeah, actually, using open source, breaking the first challenge is because if we own the code, we can standardize the API, we can debug more easily, we can do whatever we want. So we try to come up with a solution, a scalable solution to easily provision, update, and decommission the BMC. And this is what seems important for us. So first, zero-touch provisioning, fast scalability, reliable firmware boot, and seamless update process. And OK, so it's going to get a bit more technical now. So for better clarity, I'll give it back to Jean-Marie.
OK.
Thank you.
Thank you, Damien. We are going to go through a couple of use cases, which are real ones. And when you think about it, currently they are not easily addressed by proprietary solutions, whatever the proprietary solution is. And when we think open source firmware, we tend to think the same way than with proprietary firmware. But I want you to open up your mind and start thinking that the firmware can become an operating system. And when you start thinking that the firmware is an operating system, this is opening a wide range of technology which could be very helpful in these use cases. So when discussing with OVHcloud, so we try to figuring out what are the challenges. And one of the challenges is the zero-touch provisioning actions. So when you are a cloud service provider, usually you get your engineers which are located into one or two different places. And you have to deploy systems everywhere around the world. So in these use cases, you get a brand new system which is coming up into a Tokyo data centers. And you get the engineers which are based in Houston or somewhere in Lyon in France. And you have to turn on the machines. And you have to trust it. So usually the first thing that you do is that you update the firmware which is coming up from these new machines. Because it comes from manufacturing, and if you did not order a specific firmware version, you have to rewipe everything and just to be sure that you are into well-known states for your production environment. So what we have done with OpenBMC is we have started to enhance OpenBMC where we have a process which auto-detect the systems. And based on these auto-detections, we can configure the OpenBMC image to properly support the hardware. So if you are familiar with OpenBMC and with embedded Linux, usually the whole process is to build an image which is targeting a very specific hardware. And that very specific hardware goes up to the number of drives which are stick into the systems. But when you want to do zero-touch provisioning, you do not know the hardware configuration. So the first thing that you want to know is what's inside and run some kind of inventory. But you have to be able to boot the BMC image. And so what we have proposed to the OpenBMC community is to modify the OpenBMC boot flow to be able to generate a single image per ProLiant server family. So meaning that whatever the CPU your ProLiant is going to incorporate, either an Intel, an AMD, or an Ampere, or whatever the supplier would be from the CPU side, we have today the capability to start the same common OpenBMC image with a very basic startup mode. And based on this startup mode, we can discover the hardware, and we can issue some zero-touch provisioning command and build a trustable environment based on this approach. So this has been integrated within the Linux kernel. It's a little bit technical. I'm not going to go too deep on the technical aspect, but for the one of you who are interested to better understand how that works, so we modified the way the Linux kernel boots inside OpenBMC. So we are booting the Linux kernel for the GXP ASIC, which is the HP ASICs that implement the BMC features, where we start only what is needed on the ASIC just to start the ASIC, but not starting the host. So we start the ASICs, when the Linux kernel has started, we can detect on what kind of host we are sitting, and we are applying some device tree overlay to configure the OpenBMC image to be able to accept the various devices which are going to be there when the host is going to start up. So in this example, for example, we are on a system where there might be 4 different CPUs. So on the left-hand side, this is the standard device tree when the system boot up. And the right-hand side, this is the overlay which is going to be applied on the device tree. And this is going to reconfigure the device driver stack at the Linux kernel before starting the user space. It's a little bit tricky, but it works. And this is the kind of things we wanted to make work, because like that, we can start any kind of systems remotely without taking care about what kind of system is that. So previously, the engineers in Houston had to call the data centers, hey, what kind of machine is that MAC address feeding with? Because the server is coming up to the network. That's the first step of zero-touch provisioning. And the only one thing you know about the server is the MAC address. But if you need to know what kind of server it is just to load the right proper OpenBMC image, you're just screwed. So it doesn't work that way. It couldn't work that way to scale up. And that was something which was a showstopper on our side. So we modified the init ramifers. There is a lot of scriptings. We have the capability to detect the host ID directly during the boot flow at the early stage of the kernel. And based on this host ID, we applied the right overlay at the kernel level. The second thing was OVHcloud has 100,000 servers. So that's a huge amount of servers. They are deploying a lot of machines. And they need to manage system update. They need to provision them at very fast pace. Or in many cases, cloud service providers are reallocating systems to some workload to other workloads. So how can we switch workload at a fast pace? And the use case we took was something well known in the US, the Black Friday sales. So what we are seeing is that online retailers are facing a huge amount of requests during that period of the year, which are requesting, in many cases, to add servers temporarily to the Black Friday sales. And we need to act as fast as possible just to provision these machines. So the way we envisioned we could do that was to use the previous technology used for zero-touch provisioning. And instead of booting on the flash on the servers, we are booting the BMC from the network. So the main purpose of that is that all the BMC image can be prepped without the server being attached to the BMC, without having the server being touched. So keeping that this machine is currently under usage for a specific workload, and we want to switch it as fast as possible, let's say in 1 or in 5 minutes, from one specific workload to another one with a different customers, and then bring it back to the previous workload as fast as possible. So if we wanted to reflash the BMC, we had to go one by one for each servers. And then we are taking the risk of the flashing process, so it's always a scary process, because if the power shut down or if anything wrong happens during that process, you might be facing some recovery challenges. So we just wanted to get rid of these issues and being able to scale as much as we could. So we took a crazy decision which says, oh, let's consider the BMC as an OS, and let's boot it up from the network, and let's use a block storage protocol just to attach the BMC image. So we chose to boot the BMC image by using iSCSI, and we have been able to successfully boot through iSCSI. And something amazing appeared to us too, is that we are booting faster by using iSCSI through the network than by booting with the local SPI flash. The main reason behind that is that the local SPI flash is a pretty slow device, and it's very small, and due to the fact it is small, the file system is compressed on the flash. And when we are using iSCSI protocol, we do not compress the file system. So the CPU, the small CPU of the BMC doesn't have to uncompress on the file system. And this is freeing up some cycles just to process the data and other stuff that it has to process. So we got faster boot, we got easy system commissioning and decommissioning, and there is no storage limitation. If you are developing with OpenBMC, with the iSCSI boot process, we have a read-write root file systems. And you can have a full debug image too, which contains all the debugging symbols. And that's pretty efficient also just to debug your BMC environment. We are also extensively using open source technology like Core DHCP, which is a DHCP server written by Meta. And we have changed it just to accept auto-configuration of TFTP and iSCSI when it is receiving a DHCP request from an unknown system. So each time we have a new MAC address coming up to the switch and the VLANs, so we provide automatically these services to this client. And the client can issue then the DHCP request and is retrieving automatically a kernel, which is a common kernel for all the ProLiant family, and is mounting the iSCSI target. We also have some hints for the initram FS. So just to mount the iSCSI target as early as possible into the boot flow. And this is the root file system, which is mounted in read-write operation. So with that said, there is a last use case that we worked on with Damien, which is how to update the firmware. So when you update a firmware right now, you are receiving a big binary blobs, and you wipe out the whole firmware, and you just cross your finger that your bug fixes is really integrated into that update. So by booting through the network and through iSCSI and breaking the limitation of the storage capacity, we can activate what we call a package manager, like RPMs managers or .deb packages. And we can update only what is required into the firmware. So, and that is super efficient either for development or for security updates, because you do not wipe out the whole firmware. You just update what is needed, like what happened on the operating system host side. So we provided that as an example of how to manage the security. You still can update the whole image, and you can flip-flop between both processes depending on your requirement. And that was something which was really key also. We have a demo. I don't have enough time to run the demo right now. I invite you just to go to HPE booth if you want to see the whole system working. This is, we do have an RL300, which is booting from a network switches by using the iSCSI protocol and having the package manager up and running. So as a call to actions, I really think that you need to consider the firmware stack as becoming more and more on operating systems. And you really need to think about, hey, if this is becoming an operating system, how I am going to manage it? What kind of tool I am going to deploy just to make it scalable? The other thing by using OpenBMC technology, so we are just breaking the supplier vendor dependency, and we are collaborating instead of having this black box. And this is really opening up doors to innovation and new technical solution to problem that does exist for about a decade within the firmware industry. And we're pretty happy about addressing them through this process. So there is an OpenBMC Discord channel. I think the best way to collaborate right now is to join that Discord channel. I'm discussing also with the Open Compute Foundation about how to enhance OpenBMC visibility inside Open Compute. And I think that is something which is important. I'm done for the presentation, I think. Just right on time. You can test OpenBMC on HPE platforms or other vendors' platforms through osfci.tech, which is an OCP experience labs for open source firmware. We do have one hosted in France, in Europe, at Scaleway, and we do have one hosted by HPE in the US. So the upper one is the one in the US, and the second one is the one in Europe. Thank you for your time. I appreciate your presence, and let's hope to see you at the demo.